Hey guys, welcome back to my channel. Hope you are doing extremely well, and this is a very on mass coder this side. So in today's question, it is said us to discuss nearly sorted. So what does the question say? The question says it is very simple. You have been given an array, right? This is an unsorted array. This is an unsorted array. Now in this unsorted array, you have to do only one thing. You have to make this as sorted and then return it. Sort the array and then return it. So you will say it is actually very simple. You will just use a stl function, stl library function of sort, and then you will apply it to the array and then you will return it, right? You're absolutely correct. That will do the work. But it says that you cannot use the stl. You cannot use the stl. Okay. So you will say, okay, I know multiple algorithms to sort. I know about merge sort, I know about quick sort, I know about counting sort, I know about insertion sort, I know about bubble sort, etc. so on and so forth. I will use any of them and I will do the work. Okay. The problem says that I will like to amend something. You will say what? It says that I will give you a value k. It says you will give it will give you a value k. Now, the k value will decide that each value each value in the array is at most k units away from its correct position. Its correct position. What does it mean to say? What does it mean to say? So it says that for this given array, let us write on the sorted version of this array first. So it would look something like 2, 3, 5, 6, 8, 9, 10. Okay. So this 2 actually came here. So what you can say, what is the distance between these two? So you can say the distance between this 2 and this 2 is actually 1, 2, 3. Position of 3. Right? Similarly, between this 3 and this 3, it is position difference of 1. Between this 5 and this 5, position difference of again 1. Between this 6 and this 6, 3. 8 and 8, 0. 9 and 9, 1. 10 and 10, 1. So you can say each distance is less than equals to 3 and k is given to us as 3. So each distance is less than equals to k. Now, with this amendment, can you optimize your algorithm? Can you optimize the sorting techniques you were trying to apply? You could say yes, yes. So you, like, when I was seeing this question, I thought that this question does not need to be done by a conventional sorting algorithm. I do not need a conventional sorting algorithm. I do not need it. What can I say is that I have been given a value k, right? So if I take first k elements, right? If I take first k elements, sort them, 3, 5, 6. My first element is 2. So that means I need something more. So if I take first k plus 1 elements, it will give me 2, 3, 5, 6. So you can see in this sorted order, 2 is the first one. So I will put 2 here, right? This is a simple algorithm that if this position contains, like if the element on the 0th position should be at least at the distance of k plus 1, should be among the distance of k plus 1. So if I take the first k plus 1 elements and sort them, so what I'm saying is take first k plus 1 elements, sort them, smallest element will be the first element, smallest element will be the first element. What do I mean to say is that for this particular position, which elements can come on this position? Distance 0, this can come. Distance 1, this can come. Distance 2, this can come. Distance 3, this can come. So if I take all of these, sort them, then the smallest element should come here, right? Now, the smallest element comes here. That is 2 is out of the picture. For this position, how many elements can come here? This can come. This can come, right? This can come, this can come, this can come, right? And this can come, right? 0 distance 1, 0 distance 1, distance 2, distance 3. The 10 cannot come. Up till 6, 5, 3, 2, 8 can come, right? 6, 5, 3, 2, 8 can come. 2 is already taken on the first place, so 2 cannot come. 6, 5, 3, 8. That means if I sort 3, 5, 6, 8, 3 is the smallest, so 3 comes here. So what I'm saying is that it looks something like I'm adding and removing elements. I'm adding elements and removing smallest elements, to be precise. Smallest element. So I have already studied a data structure basis on this. What does that mean? What is the database or data structure known as? It is known as min heap. It is known as min heap. Yes. So my intuition is to use a min heap. What will I do? I will just show you. Let me write down the example again. So it is 6, 5, 3, 2, 8, 10, 9. K is given to me as 3, right? We just discovered the 6, this position can take 6, 5, 3, 2. That is first 4 elements, right? Because distance is 0 here, distance 1, distance 2, distance 3. That means I need 4 elements. That is K plus 1 elements. K plus 1 elements. So I will create a min heap. I will create a min heap, right? I created a min heap, right? I will add the elements. So min heap means top element will be smallest. So 2, 3, 5, 6. It will internally arrange it like this, right? Now, the first element will be how much is 4. 2 is the smallest element, so 2 will come here. So I will remove 2 here, 2 will come here, right? Now, because I am coming on this position, which elements can come now? 6 can come, 5 can come, 3 can come, 2 can come, 8 can come. 2 cannot come because it is already been required. So what will I do? I will add 8. I will add 8. After adding 8, 3 is the smallest. So add 3 here, right? Again come to here. Now 10 can also come. So add 10. Add 10. After adding 10, 5 will come here, right? So 5 is also removed. After adding 10, for this position 9 can come. So 9 is here, right? 6 is the smallest, so 6 will come here, right? After that I cannot add anything. Then 8 will come, 8 will come here. 9 will come here. 10 will come here. So what is happening is I will just add one, I will just remove the top one, and I will add it to the answer array. Are you understanding my point? I will just remove the top one and add it to the array, and that's my answer. So what I've done is I've done something like this: insert K plus 1 elements, right? Then remove top, add next. This is the procedure I am following, right? This is the procedure I am following. What is the time complexity? So because at all times my min heap size is less than equals to K plus 1, less than equals to K plus 1. So I am taking time of log of K plus 1 to insert n elements. To insert n elements. So n log K plus 1. N log K plus 1. So let me write down the code for it. I hope you are understood the question. It is actually very simple to understand why are we using min heap, right? Let us go to the coding section. So here is the coding section, guys. So let us first take the size. So int n equals to array dot size, right? Now let us create a priority queue. So priority queue, which will be taking int. So it is a min heap. So it is a method to create a min heap using STL, right? Let me name it as pq only. Now for first k element, that is, let me take something like this: int I equal to 0. So while I is less than equals to k, that is first k elements, first k plus 1 element, sorry, pq dot push. What do I push? Array element, and after adding it, increment y. This is that is why I'm using post increment here, right? Now I will have to fill up also. So ptr equal to 0, that is, it will start from the 0th position, 0th index to fill in. Now while my ptr is less than my size, that is, the array is completely not reformed, what will I do? I will first put the elements. So array of ptr, after adding it, incremented, is equals to pq dot top. That is the top element. You have used the top element, so pq dot pop, right? And if there are additional elements present, so if I is less than n, then pq dot push. What do I push? Array I plus plus. After that you can simply return, because it is a void type function. You just have to sort the array in place. Completely running fine for the sample test case. Hope it will run fine for the test case also, hidden test cases as well. It is running fine. So thank you for watching. Hope you liked it, and make sure to like and subscribe to the channel. Thank you. Have a nice day.